Lifetime of a machine part is exponential, mean 5 years. Find the mean lifetime given that it survives less than 10 years. So let x be the lifetime of the machine part. Then since the mean is 5 years, so the little f of x would be 1 over 5 e to the negative x over 5. We're given it's exponential, x greater than 0. And the big F would be 1 minus e minus x over 5. And we are interested mean or expected value of the lifetime given that it survives less than 10 years. So we have to find expected value of x given that x is less than 10 years. So survives less than 10 years means lifetime is less than 10 years. So to calculate this conditional expected value, we need the corresponding conditional probability function. So we need f of x given x is less than 10. So now f of x given x less than 10, on the top, you'll have probability f of x and x is less than 10. So maybe we can even write this part in the parentheses. So f of x and x less than 10. And in the bottom, you have probability x is less than 10. So because that's the given part, x less than 10. So now f of x and x less than 10 means f of x, but now x has to be less than 10. So look, the normal bound of x is x greater than 0. So actually it's from 0 to infinity. But since we are conditioning it at x less than 10, so it doesn't go all the way up to infinity, but it stops at less than 10. And and the bigger than 0 was part of the original thing, so it was bigger than 0, but now the condition is also stopping it at 10. So f of x on the top, so this less than 10 part is written over here as the ultimate condition. And then probability x is less than 10 is the big F of 10. And then we substitute the values. F of x was 1 over 5 e to the negative x over 5. And the big F of 10 is obtained by substituting 10 here. So 1 minus e minus 10 by 5, and it's in the denominator, so 1 over. And then this part, and then you combine it with the 1/5, that simplifies to 0.2315, and then we have e to the negative x over 5. And now we have the probability function that we need for this expected value. So expected value of x given x less than 10 would be the integral of x against this probability function of x given x less than 10, which we found out to be this one. So I pulled the 0.2315 out, and e to the negative x over 5 is left inside. So remember, in an earlier problem, we mentioned this shortcut for this kind of integration by parts when you have x e to the ax. And I mentioned that that's just equal to x e ax over a minus e ax over a squared. So in this case, a is negative 1/5. So I have the 0.2313 out. So just substitute a equals negative 1/5 in this expression. So negative 1/5 here, negative 1/5 here for a, and negative 1/5 in the denominator, and similarly here and here. And then when you saw the limits of integration were 0 to 10. And substitute 10 here, x is 10, and then this divide by negative 1/5 makes it negative 50, and then 10 over 5 is 2, so negative 50 e to the negative 2. Similarly over here, this is 25 when you bring it up, and so negative x negative 25. And then remember, this negative is killed by the square. So negative 25 e to the negative 2, because x is 10. So 10 over 5 is 2. So that's negative 25 to the negative 2. So that's the upper limit 10. And then minus, when you do the lower limit, this is 0 because x is 0 here. And then, oh, this should be negative. Because this negative is killed by this square. that becomes positive, and we still have this negative. So minus 0 minus 25 e to the 0, the lower limit is 0. And then when you do all this, it simplifies to 3.435. That's choice E.